of the biggest, 120 the volume of the TSPP talk, and then I'm happy to introduce Ryo. Ryo Suzuki is the assistant professor at the University of Colorado Boulder and at the Institute of Department of Computer Science, where he directs the program of Programmable Reality Lab. So before joining Boulder, he was also an assistant professor at computer science at the University of Calgary. And then his research mission is to enhance human thoughts and creativity by transforming the entire living environment into dynamic space and for thoughts, where people can think through the tangible and the spatial exploration with real objects in the real world, not just with virtual objects on the screen. So since he been publishing many papers in HCI, human computer interaction, and robotics, and also some user interface technologies. So today we're gonna see tons of his invention of how we can transform the spatial environment into more for creating enhancing our creativity and thoughts. So I think that his research field is basically human computer interaction and also computer science, and how we can use this technology to enhance our capability. And then I think this also inspire you to how you can use those technology to enhance your creativity on your research, I think. So I think from that point of view, I think his research also could be highly impactful for the activity in the OIST. Okay, so now Mike is yours. Thanks.
Well, thank you so much for the introduction. Hi, my name is Ryo Suzuki. So I am currently assistant professor at University of Colorado Boulder in Department of Computer Science and Atlas Institute. And today I want to talk about augmented human thought and creativity with the power of AR and AI. But I usually kind of give a talk to the computer science audience, but I think you may know the AI, but does anyone who don't know the augmented reality, like AR or VR? I think it's probably okay. I can also give you some of the examples, but augmented reality is somehow kind of, like a Pokemon Go, like moving from the computer screen or the mobile phone. In the future, we kind of believe that like a visual content, virtual content can be embedded in the physical world or through the glasses. So that is kind of like a topic that. But before jumping into the talk, let me just kind of briefly introduce myself. So I am originally from Japan and I graduated from the University of Tokyo back in 2015. And then I became a PhD student at the University of Colorado Boulder. And during the PhD, I also did some kind of internship at some of the university as well as industries such as Microsoft and Adobe. And then I became faculty at Calgary 3 years. And then in the meantime, I also worked for the Google. But my family kind of complained about winter of the Calgary. So I returned back to the Colorado border 2 years ago. So I'm now kind of assistant prof at the Colorado. So my research area is mainly the computer science, more specifically focusing on human-computer interaction. The reason why I'm kind of quite interested in human-computer interaction is because I believe the interfaces and the representation can actually going to change how we think. So let me just kind of give you an example about what it means about representation interfaces can augment the human thought. So here's a simple arithmetics question. Can anyone solve this at the moment? And then what about this? So maybe now you can immediately understand and solve it, in your head, right? Then it's kind of interesting because the data is the same. I mean, data is the same, right? Because one is a Roman numeral, another one is Arabic numeral. And your brain also hasn't changed, right? But what has changed is just kind of representation. Or I would say like an interface to interact with your brain with the number or the data, the digit. So as you can see, this kind of example shows how representation or the interfaces can actually change how you think or understand the world. Here's another example. So back in like a 17th century, people make sense of the data by just looking at a table like this. So but back in like a 1786, the William Playfair invented the technique called data graphics, or nowadays which called like data visualization. And then now you could see the data rather than read the data, right? And then now you cannot imagine the world where there's no data graphics here, but this is somehow artificial invented works, right? And then how such kind of representation of the graphic representation data can change how the symbolic representation of the data to think about it. So that's why like I'm very interested in kind of representation interfaces for human thinking and creativity. And I believe computer and AI are also very powerful tools to augment human thought. For instance, like an interactive data visualization rather than just data on the ink and the paper. Like if you just kind of interactively see the data, and which allows you to make sense of data much more easily and briefly. And also such kind of dynamic physics simulation tool. So this is a kind of from University of Colorado. But that's such kind of the dynamic physics simulation tool also allow us to learn like complex mathematics, the physics concept. And also more recently, as you can see, like a powerful AI tools like a ChatGPT can actually change like how we think, learn, and create ideas drastically, right? So that's why I believe the computers and the AI are very powerful tools to augment human thought. But one of the problems is the current interfaces or representation of media does not really help how we think in the physical world, because that is kind of limited and constrained into this tiny rectangle screen. But when we reflect about like how we think in the physical world, it's kind of much more rich and a very expressive way to think about it. For instance, we use the kind of space like discussing around table, or we also kind of use a physical and a tangible tool to manipulate and organize it. We can also walk around or look around the physical and spatial orientation, and then also we use a tangible physical paper to kind of scatter and organize ideas and then kind of discuss spatially. And the people tinker things, like make things, like learn through like a moving object in the hands and the body and the math. And so that kind of the rich, tangible and spatial and embodied interaction actually gonna show that how rich our way of thinking and understanding and learning is, right? And but when we think about learning, thinking, and understanding with a computer, it's just constrained into this tiny rectangle screen, ignoring the entire rich physical and spatial interaction that surrounding us. And we have to think in this tiny rectangle screen, which kind of frustrates, because I believe, as I said, like a medium and a representation can untap how we think, and the currently the computers and AI just a tool for thought, but such kind of tool for thought is just constrained into this tiny rectangle screen. So my goal is kind of trying to change this paradigm into like a transform, instead of just kind of into this rectangle screen, into the space or entire environment can become a dynamic and computational medium to think and learn, as if like a physical media to live in rather than live with. So which I call like a dynamic space of thought. So it's more like a dynamic, not tool, but dynamic space for thinking and understanding. And here's my vision about the future. So where like people can like learn and understand through the actual like interaction with the spatially and understanding, and also you can communicate and like discussing in a spatial manner, and also you could kind of discovering and browsing things, and also exploring and drawing and creating things. So that is kind of how I envision the like a future look like. And I'm kind of trying to make such kind of dynamic spatial thought to bring it to every single room in every home. So I think back in 1980s, Bill Gates bring the computer or computation medium to every desk, and people love it. But now we have a computer in every desk. But I rather think the future could be bring such kind of dynamic computation medium into the every single room in every home. So that is what I'm kind of envisioning. So just like downloading the app, but downloading the space itself, like an entire science museum, so that your room can become like a dynamic medium to think about it. So that is kind of how I kind of trying to aim for it. And then the one key challenge is, and the question is like how to blend such kind of virtual and physical object environment in a different room. Because unlike just downloading an app to the same screen, your room and my room is completely different. So it has to be intelligently recognize our environment and understand activity and embed its response into the real world, so that the virtual elements can seamlessly blend it into the physical world. And to solve that kind of problem, I am trying to combine the augmented reality and AI as a means to drive these things forward. And toward this goal, I have been making a 3 key contribution in the 3 different areas. So first one is AI-powered augmented reality content creation. And the second one is make such kind of a tangible augmented reality ubiquitous to every different room and every different object. And the third one is how to augment human-mediated, AI-mediated communication. So let me talk about the first one. So the first one is about how can we automatically generate an interactive augmented reality content that can adapt and augment the real world. So let me give you an example. So as I said, augmented reality is something like a Pokemon Go, but it has been kind of rich history over the decades. So one of the applications is kind of learning and educational content. For example, here's the augmented reality textbook, and where you can kind of scan the textbook and then can see the 3D version and animated version of the herd like this. So this is great actually. But one of the problems is this specific dynamic 3D content only works for this specific page of this specific, right? And then if you just kind of scan the different books, and it doesn't work because you have to prepare and then the program such kind of AR content beforehand. And to make it happen, you have to kind of create AR content for every single book, but it doesn't work. So that's why it's not really scalable for many different contexts. So to solve this problem, we have done like a new type of approach, which is called augmented math, which is kind of AI enabled. So using the AI to generate such kind of dynamic content in real time for non-prepared content. So before kind of showing the video, let me just kind of quickly show like a demo. So this is a kind of, actually there's an AR version of it. But here's kind of scanned math textbook that I got from kind of random math pages. And here's the kind of static graphs here. But if you just kind of click this graph and also link one of the like an equation, and now you can kind of start interacting with the graphs to see, oh, this can change this x-axis, and this can change the y-axis. Okay, what if if you change here, oh, the slope is gonna be changed. Oh, so this is kind of like a 2 or 3, and then how it can interact with it. And then again, this is not something like that I prepared beforehand. So you could just kind of explore. Oh, for example, okay, what if if you just kind of select this one, okay, if like a sine curve gonna change in this way or something like that. So this is something it's like a machine learning driven one approach, meaning that you can just kind of scan it and then generate such kind of content on demand without preparing this kind of data. So that is the what we did for the augmented math. So in the actual system, this is a kind of camera-based system, so that you gonna look at the document, and then you could also gonna interact with it, so that this can be like makes a static augmented static math textbook, dynamic and interactive, so that you don't have to imagine like what happened, but you could also kind of learn and understand through just kind of interacting and also manipulating the data. So this is kind of like what I mean by like we are living in Roman numeral era or dynamic content. So if you have such kind of dynamic content, then you could see and understand and learn much more differently. So yeah, so these are kind of simple example, but the actual contribution here is that we kind of had a machine learning and an automatic pipeline that extract the graphs by looking at like a textbook, and then the automatically kind of generating and linking between the math equation to the graphs, and then generates the dynamic version of it. So that like you don't really need to like prepare for this specific one, but whatever kind of pages that have the graphs can be augmented. And then later we published it, and then Apple also kind of created like a dynamic math notes like this. But I heard, yeah, this is somehow the kind of I'm kind of glad like it's somehow inspired this kind of dynamic math sketch interaction that can kind of scale it to the many different people. And then after that, we also kind of try to extend such kind of notion into the different domains. So instead of math to the physics or the chemistry. So this is one of the papers that we had a best paper award at the OIST 2024 called Augmented Physics. But let me also show you just a quick demo. So again, like this is also supposed to be the actual kind of camera-based AR content, but here it's just a like a desktop version. But here, imagine that you are also reading the physics textbook, which has a diagram like this. And as you can see, like what happened gonna be, you have to imagine, but what if you could also just kind of say, okay, just kind of quickly interact with it. And then now you can kind of start simulating the physics diagram like this. Again, like this is not animation, but you could also actually gonna, try to interact with it. And so this is simulation. So what if you could also kind of change the parameter? For example, here the mass is 80 grams. So what about 800? And here's the friction is 0 right now. So what about 1? And then you could see, oh, the behavior kind of change because the friction is a little bit, high. So it kind of moves slowly. So as I said, like this is not really prepared content, but you could just kind of look at the textbook and then kind of start making a simulation, even for the non-polynomial. So for example, like here's the kind of non-conventional, like a non-conventional diagram like this, but you could also just say like a selected, and then now we can kind of try to segment it and extract an object like this. And we could also, for like different type of the application, and you could also see, like how the lens can behave based on like a focal point or the object moving like this. And also like for the circuit diagram, you could also see the like a circuit by kind of looking at the diagram by kind of simulating like this. So this is kind of how we did it. So it's kind of based on the combination of the computer graphics, which kind of trying to understand what's inside of the images. And then we extract the image content, such as, for example, in this case, a slope, and also the person object, and then it makes the physics simulation based on this content on demand before and in the background. So everything is kind of very interactive. So you don't really have to, like just looking at the animation, but you could also kind of change the parameters or to change the behavior by looking at it. So again, like these are pretty much for mostly kind of like a very simple physics simulation. But it kind of works for, any kind of like a physics textbook that has a kind of diagram. So we are only right now just focusing on the 2D graphics, but it doesn't really have to be 2D. We are also trying to extract 2D content to generate like a 3D dynamic version of it. For example, like if you look at a skeleton in a textbook, then we could also extract it and generate a 3D version of it. And also like interact with the like a chemistry, like a cars or even like a creativity such as kind of. So these are technically challenging because we don't generate the 3D content, but also we have to animate the interactive 3D version of it. But we are also really interested in kind of making things happen for this through this angle. And these are only for the like a math or physics, focusing on math or physics textbook. But we are also interested in like, what if we can augment any kind of texture content. So to do that, we did a kind of the like a LLM version, like a ChatGPT version, or the like a document enhancement. So here, this guy is kind of wearing glasses, and then this guy can look at the page, and then you could see the kind of additional content, such as kind of what the differences is, or what the keyword is. And then based on the keyword, you could also see the images or the table and also on the maps, also by automatically extracting the content from the physical document, like this. So what happened here is by looking at that document, like a pages, and then we kind of extract the content by and a text, and then using the ChatGPT GPT-4 here, and we can generate a summary, timeline, and a keyword list, and the information cards on the table. And then we generate and then show this kind of additional content centered around the document in the glasses, in the glass, such as like a summary, table, and a timeline, and like a keyword list, and like a highlights, and then a color. So one of the interesting aspects of this product is we actually deploy it. So because this can basically work for any kind of texture content. So we recruited people and then actually use it in their daily lives. So they look at the posters or the paper on the wall by kind of asking the question, or they also kind of, like while reading a textbook, they also kind of enhance the, document. But also interesting finding is they didn't stop at just a reading document, but they also kind of start looking at the text around the world. So one of the interesting application or use cases was, they look at the menu on the cafeteria and ask like, what's the vegetarian menu, and then, or even like what the healthy menu is, and then like start question and answering through the AR glasses with an AI. And also they kind of look at like which disposable like a content should be in, and so on and so forth. So this is kind of pretty interesting findings, and we are also kind of focusing more on like what kind of the real world AI interaction in the future. But to summarize, the first category is like we are interested in how augmented reality content can be automatically generated by using AI content creation, and essentially focusing on educational and learning context. So that is the kind of first blast. And for the second contribution, we are also interested in like, how to make such kind of tangible physical augmented reality content interaction more ubiquitous. So this class, the motivation comes from when I come from the experiences when I was teaching the classroom. So I'm currently teaching a mixed reality and augmented reality class, and in this class, and a student usually kind of creates like a application like this. For example, you have like you're gonna grab some kind of physical dishes, and then you kind of manipulate like a virtual car, for example. So this is kind of interesting and a great application. But making and creating and experiencing such kind of application is notoriously hard, because you really have to kind of track the physical object, so that you have to put the sensor on it, And then you also manipulate and interact with the virtual car. So usually they spend like a weeks or even like a month to create such kind of very simple application. But when we kind of trying to democratize such kind of experiences to non-technical people, like a scientist like you, to just kind of quickly make it, it doesn't work. So that's why like we created the system called like a teachable reality, which is allows the non-programmer to just generate and quickly such kind of experiences. So the teachable reality is kind of using everyday physical objects such as like a dishes or a cardboard color or the cars, and then you generate and create these kind of interesting interactive experiences and application in seconds rather than hours or days or months by using like a technique called interactive machine teaching. So idea behind it is it's basically kind of trying to learn trying to demonstrate it to create it. So here, for example, if you use this physical object as a slider, you first kind of trying to capture like three different position of the finger, and then you're gonna place like an object like a tree, and you're just gonna link each one of them to each one of the state here. And then we just kind of train the machine learning model on demand, and then we can recognize the three different states by three different states of the finger position. And then the corresponding it, we also kind of change the three sides like this. So by doing it, we can make a lot of different type of applications, such as using like an everyday physical objects, such as dishes, to interact with these kind of objects. Or you could also make the context-aware, assistant, or the paper augmentation and a body augmentation, and so on. Because that one is just kind of capturing, like using the camera, and then just make a pose, and then make a different stage, and then you can kind of create such kind of interactive application. So it's very easy and limitless without making the sensor data or the making application. It's kind of many different types of it kind of untaps the use cases and application for non-programmer students. So some of the, actually in my class, there are also some like a physics or chemistry, like a non-computer science students, but they can also kind of use this kind of tool to imagine their own application or to kind of interact with it. So that is very interesting for me. And then beyond that, like we are also kind of moving this forward to not only for like just a prototyping, but also more like for presentation, lecturing type of application. So here, the project called like a reality sketch is you can kind of sketch just like a whiteboard. Whatever you sketch in this iPad, like augmented reality content, can become dynamic. So for example, here, like if you just draw a pendulum attached to the physical object, and then what you sketch here is gonna be automatically dynamically kind of embedded into the physical world, so that you can kind of demonstrate and show like how pendulum works, and by showing the graphs in the physical world. So idea is simple. So whatever you sketch here can become like attached to the physical object. So the physical object here is a pen, so the light pen, so that if you move it, like these kind of sketch elements gonna be attracted. So this can be useful for example, showing like how deflection can be happen. And here's the, for example, like how the middle angle. You could also make a constraint so that how the middle angle can also change for the math situation. So we created so many kind of different types of scenarios, such as kind of enhancing like a physics classroom, especially kind of experimental like a physics classroom for elementary or middle school student, so that like a people or the even student can draw the thing and then like visualize thing to see what happened by learning by just kind of experimenting. Or you could also kind of like use the math. For example, here is the conceptual demonstration about like how the different ratio of the gear can change the traversal between these two, so that like they can, again, like it's more like gonna make your classroom just like a science museum, so that like they can just kind of create and interact with it. And it's also not only for the like educational content, but here you see like how the like a yoga posture or the exercise posture can kind of track and visualize it. And also like you could turn like everyday objects into like a dynamic, like a sliders or the manipulators of the physical virtual object. And we also kind of enhance such kind of the application to more like a freehand sketch exploration. So here, if you sketch it, and then you could also attach to the body, and then you can make like an animation, also. So these are more like a creativity aspect about like how, what if you can, instead of just kind of, what if you could see the like a sketched animation on demand, instead of kind of waiting for hours of the video creation. And one of the applications here is that we actually going to collaborate with the performance artists and who use that kind of system to augment their kind of dance performance to generate like movies or like generate videos to enhance it. And also some of the teachers also use it to enhance their kind of lecture recording to create like a enhanced presentation, which I can also talk later too. So as I said, like one aspect of this one is like making such kind of seamlessly blending virtual content into the physical world is hard, but we are kind of trying to make it more simple and ubiquitous by democratizing such kind of for non-technical people. And then the third one is about, we are also going to try to augment and enhance human-to-human communication, because that's how we generate ideas between it. So one of the motivations is from the, like he's a Hans Rosling. He's an expert in public health, but he's also kind of very famous of the data graphic, data visualization process. He also wrote that book called like, Fact. So maybe some of you may know. So this is kind of one of the interesting demonstration, like how he communicates the public health knowledge into the general public people. So he doesn't use the slides or like just the books, but he actually gonna use, created such kind of the data graphics video, where he talked about like how like a poor country can become richer by over the time by using his body and generating this kind of data graphics interactively and then embedding in the real world. So this is really inspiring to me, because nowadays we are kind of stuck with like a slides or presentation like that. But this can be also the future of the presentation, or the future of the communication between the scientists and the general public. But one of the key challenges here is, it's kind of like requires a lot of time for the programming and the video recording. And also more importantly, it doesn't work in real time. So it cannot, do it right now in the live, but you have to kind of record it, like how to do it. And then you have to kind of synchronize between your motion and the video, which is super tedious. So that's why like we thought about it. What if we can kind of generate such kind of dynamic enhanced presentation in real time by using like a speech-driven approach? So here's what I mean by speech-driven approach. So here's one of the demo created by my undergrad students.
Hi, my name is Magrat. I'm an undergraduate student at the University of Calgary. Today, I want to talk about augmented presentation. As you can see, when I talk about something, we can augment the presentation using an augmented reality interface. We have several features. We have, for example, live kinetic typography, embedded icons, embedded visuals, and embedded annotations to physical objects. all components are interactive.
So as you can see, like, maybe you can understand now that what he is talking about, the video kind of capture like what he's talking about in real time, and it shows you this kind of clip and also associated images on demand, so that you can generate this kind of augmented presentation in real time for the live performance. So to design such kind of system, we first started kind of analyzing like hundreds of the YouTube videos and thousands of the scenes that uses these kind of techniques on YouTube. And then we understand like what kind of the, how they use their bodies, or what kind of the information should be shown, and then when. But analyzing this, analyze existing videos, and then created like proposing the system that uses like a voice-based input as a trigger, and then generate dynamic information that can be manipulated with the body. So here's one of the application, for example, like for the teaching.
Hello.
So here.
Today we're going to discuss white blood cells and killer T cells. In particular, we'll talk about the HIV virus and how it attacks the blood cells and hides from the T cells. We can see this displayed through this diagram of the immune system. Now we're going to show a quick video demonstrating this process.
Yeah, and here's another example.
Let's introduce this new water bottle. It has so many benefits, including double wall vacuum insulation, this flexible perforated handle for easy use, and it's dishwasher safe. You can bring it with you to so many different activities, including going to the gym. You can bring it to the outdoors. If you like, you can even bring it to the pool.
So as you can see, like here, like you like based on the speech, based on the speech, you could also kind of generate this kind of like title and also like images associated with it, and then you could kind of manipulate it. So this is kind of how we envision the future of the presentation, where it uses kind of live conversation, communication, and also visual and spatial and embodied representation about your words, right? But also it's not only recorded, but it's also not only prepared, it's kind of synchronized. And yeah, another application, we also did a kind of like a similar approaches for like a data graphics, data visualization, like data storytelling. So here, like using a tangible and a physical object to talk about data, such as how the calorie can change between where just gonna nutrition facts of the object. So everything is kind of improvised on live presentation. So we are kind of trying to design the future of the way of communicating ideas between people. Because the slides has been invented with somebody else, but it doesn't really have, there's no need for slides. So we are kind of thinking about how we can augment the human-to-human communication for the future by using both augmented reality and AI to enhance communication. And communication is not only for the presentation, but we also have a conversation, right? And where the idea is generated. So we also want to briefly talk about we kind of did it like a conversation version of it, which is like a before ChatGPT. So the idea is like just kind of extracting the keywords from the conversation and then looking at like showing like images or related maps around the conversation. But yeah, maybe you can get the idea of how you could use such kind of system to enhance the communication. So this was the kind of first trajectory about like how we can also augment the AI-mediated communication. But by using just a couple of minutes, I also want to talk about like a future research direction, like where we are kind of going to. So I believe like a generative AI is a very powerful way to move it forward, especially, for example, image generation, text generation, video generation nowadays would be very, rich way of the communication. For example, like I've been kind of collaborating with Shuichi and Kapara to, use the AI clone as a communication for like science to the general public. But I think beyond that, we are also interested in how such kind of experiences can enhance the real world interaction and augmented interaction by using augmented reality. So which I call like a generative augmented reality. So as I said, like my original, motivation was like how the representation can change how we think. And currently, like an AI tool, like a ChatGPT, is mostly textual representation or symbolic representation, right? So meaning that you have to kind of watch on the screen or the smartphone. But I am envisioning the future of representation should be more embedded and spatial and interactive. So here's let me give you a kind of quick example. So when you're in a kitchen and if you ask what kind of recipe you can make, then most likely what you can get on the smartphone is just some textual recipe, right? Right. So the step 1 here and step 2 here, but you have to read it and you have to kind of go back to the kitchen to to synchronize it. But we are kind of thinking about this is not really very suitable representation. So the suitable representation should be you are in the kitchen. So you should be able to see like what you're gonna do next, and it's also embedded in the physical object. So for example, if you ask the recipe to the ChatGPT, ChatGPT should respond in a physical way. So where you should kind of put it, and you also can see like a timer on the top and when you stop the fire and so on and so forth, right? So this is kind of how we believe the future should be and the AI. And here's one of the prototypes that we have making. So here, it's a augmented reality instruction tool, but instead of kind of asking ChatGPT and getting the text responses, we automatically create like an embedded version of the instruction. For example, when you ask how to use this kind of printer machine, and then how to clean the printer machine, and then as you can see, the instruction is automatically generated as animation, so that you could just see it and to what you're gonna do next. So that is like a much more rich and easier to understand what's going on. And the more important thing, it's actually gonna completely 100% automatic. So you're just gonna ask ChatGPT and we generate this kind of dynamic instruction based on what you're looking at in the camera. It's a kind of automatic way. So to do that, what we did is like by analyzing what ChatGPT is responding back with the text, and at the same time we also capture it and detect like where the object is and localize it in a 3D position, and also segment the object in the scene so that like we can kind of generate like a highlight, like a move, like hand gesture and so on. So again, this is just kind of one of the glimpse of the future about like a ChatGPT. Now you understand ChatGPT text is not really useful in the physical world, but we should be, right? So we should use such kind of rich spatial interaction. So I just want to say like we are still living in a Roman numeral era of the AI. So the text representation is not a suitable way. But we kind of trying to invent Arabic numeral for the AI. So that is kind of what we are kind of trying to do by analyzing the physical world. So that if you ask, like even for the simple question answering, such as like what's like the size of this table, and you could see and embed it in a physical world. So that is kind of what we are kind of trying to embed. So for example, when you also kind of analyze on the whiteboard, and you could also see and kind of generate like a dynamic version of it. And then lastly, I just want to quickly talk about for the how such kind of the content can also enhance our entertainment content. So here's the project called a Cinema World, where you are watching on a movie in the room, but instead of just kind of watching in a 2D screen, here, like based on extracting the content from the movie content, you can kind of transform your room. For example, when you're watching a rainy scene and your room is kind of start raining by using the glasses. So in the snow vision, you could see the snow and change the entire room to match to the content that you're watching it. So as I said, like, by using generative AI, we can extract the 3D content and generate 3D such as letter or the ads like this. So everything is happen automatically. So without analyzing it. So that like, it's kind of like we kind of imagine that Gen AI is not only the image generation or the video generation, but we can also now programming the real world. So that's why like we call it like our lab called like programmable reality lab. We think that AI can go beyond just kind of text or AI images on the screen, but we can kind of start, interacting and replicating in a 3D scene. So I believe this kind of the direction it just started, and we are kind of trying to, make things happen in a different, in a different application. But overall, we are kind of trying to build a future of the generative augmented reality to not only enhance for the, like a 2D or 3D content, but actually kind of trying to make the entire room, like every single room, into dynamics interactive content for thinking, learning, and understanding. This should be very, and so we're kind of trying to invent Arabic for the AI. So that's pretty much it. And as I said, we are the programmable reality lab at the University of Colorado Boulder, and we have a couple of PhD students. And I also want to thank all of the collaborators and also like a research institute and also the sponsors that help us to make that happen. So that's pretty much it. So thank you for listening to my talk, and I'm happy to take any questions.
Great. So like thank you so much for talk. And then now is anyone have any question? I think maybe I can Mike is here.
Thank you. I have two brief questions. One, first, how difficult would have been to deploy any of those things here right now? Could you have done it as a demonstration?
So for instance, for instance, like this thing can work for I think here too, and this movie thing is also can work. So do you have a meta? No. Oh no. Okay. But if you have it, maybe you could actually test it out. Yeah.
Okay. And then the other question, all of this is super impressive. Have you been studying what the psychological response of people is going to be? Because I feel really overwhelmed by the AI that's on the screen. So to see this all around me.
I mean, that's why I collaborated with him. So that he's more like an expert in the psychological experience side, where I am kind of trying to learn it. So we are doing some kind of very simple usability study, such as like how enhanced movie can be more entertaining or immersive. But we didn't really do how to say like a behavioral change or any kind of like a long-term metrics yet. But we are very interested in that.
Yeah. So in the real-time augmentation of the presentation, so how can the presenter monitor what kind of augmentation is happening, and how can he or she control the type of augmentation?
Yeah, that's a really good question. So this is a kind of actual system diagram. So let me also kind of briefly talk about the like a history about this project. So we originally just trying to use everything is like a auto-generated in real time. For example, like whatever I talk, like I just get like a Google images from the Google and I show it, and it turns out it's so messy and very how to say very distracting. So that's why like we kind of did a kind of hybrid approach where the user first kind of trying to how to say like list the keywords and associated images, but the user is kind of trying to, how to say, say some kind of keywords, and then it's just show the images. And then in terms of the, as you can see, in terms of the how to control in real time, for this specific one is the more like when we did it in a COVID era, so where when we like a Zoom kind of presentation is more common. So in that case, like we just kind of see the camera here, and we see it in like a Zoom presentation. So we just kind of see it and kind of manipulate it. But for more kind of in-person presentation, I think we might also have to see, like how we can kind of synchronize, manipulate it. I think one of the possible way for the future is assuming using like a glass, so that you could see like what you are kind of manipulating in your environment, and it's also kind of synchronized communicated. So that might be the way. But this was done during the COVID era back in 2021. So we focus more on like a Zoom type of.
Thank you. Do we have anyone question? I actually have one question to you, because like I really like your idea and also project wise, and because like it's like actually augmenting the spaces, and then not only the entire screen, a small screen, it's more like we can also leverage the spatial information. Then it feels like, do you think this kind of like expanding workspace using some spatial information, do you think this can also really enhance human souls or human cognitive process? Because like sometimes we are working on some small screen and then thinking about deeply in the data. Sometimes more for like a kind of like downgrading the level of the dimension sometimes help us to thinking about a little bit like a deep, like an abstract way or something. So like sometimes might be always having some larger space. It's not sometimes best way. So yeah, I just wanna ask you this.
Yeah, to precisely understand like what happened, we also actually gonna need more like a precise usability or psychological study. But I just want to mention that like there are two, there are kind of two different like category. One is kind of different medium, and one is a representation. And what I'm talking about representation is because, for instance, you are reading the books with just kind of physical books, right? But if you kind of use a Kindle or the iPad, the representation is still just a static book, right? For example, you cannot watch the video on the static book, and then now iPad allows you to watch the video. So that is kind of how the different medium enable the different representation. But if you just only reading the PDF, then it's not. I mean, the medium is kind of changed, but representation is same, right? So I believe the more interesting question to me is not just only extending what we have right now. So for example, like if you have the kind of larger screen, then maybe right now we can still do it, right? But I think I'm more interested in like a different type of medium, such as augmented reality enables representation that couldn't be done in actual like to this screen. So one application, like one example is like a 3D generative. So I'm more interested in kind of trying to find or investigate the the representation that doesn't exist now can augment thinking rather than just kind of yeah.
That is very interesting. So okay, do you have any like a thoughts of the ultimate representation with the science or something?
Yeah, I mean that's why we're kind of trying to prototype things. So the way we kind of trying to discover is kind of a lot of kind of prototyping and experiencing. So that's why we are also kind of trying to accelerate our own research by using Gen AI and AR. So that before we spend like a couple of months to prototype experiences, but now we can kind of do it in a day. So I think that's also how we kind of try to accelerate our own scientific experiment to kind of prototype different types of representation. So there's no kind of, single answer to do it. But as for example, like a Feynman invented like a Feynman diagram, or, like William Playfair created data graphics, a lot of kind of struggles in the prototype, right? So I guess that's the kind of how we're doing it. And we hope like maybe at some point we can kind of make something makes unthinkable thinkable, for the science, scientific knowledge.
We have one remote question, so very short. Like, have we made or do you know of any research of AI, AR for blind people?
There are. So one, I actually do have a couple of like differences. So if you, let's see. So for example, UW Makeability Lab, University of Washington Makeability Lab is one of the group who has been doing like a AR for like a blind people. Another one is at the Hongu at the University of Michigan has been also doing AR interfaces for the blind people, especially for navigation kind of thing. And also in the Japan, it's not specifically for the AR, but Chieko Asakawa in the Miraikan has been also working real world navigation for that. So I guess it might be a good, pointer if you're interested in.
Thank you. So hope like the person who made a question hope get information.
That's kind of.
All right. So thanks so much everyone to come, and then I think Ryo will stay OIST until next week. Not next week. 28, 29, something like that. So you can also grab him to talk about more about like.
I'm also really interested in learning what's happening here. Let's talk.
All right. Thank you so much for coming, and then let's thank again for your